Oh.
I'm gonna get a baseball.
Dan, are you on Facebook?
Nope.
Oh. Really?
Really?
Dude, let's
I
make her
made
one.
an account for you.
You made an account for me?
I thought someone else did.
I think we thought about doing that last year.
With
Yeah,
what,
let's
my
do
last name Noel or Den?
Den no.
Then no.
Look, I didn't look it up. I'm just asking. I thought you mentioned it. Not that much of a freak.
Really?
I don't know. You asked a lot of questions.
Yeah.
I'm just interested in people's lives.
You were in 3rd grade.
Yeah.
You're having a good day.
I'm doing it on purpose. 2 in 1 day.
I just thought I would like to spell it stupid. It's stupid. It's so stupid.
So today we start with this stupid definition.
We should have an exchange program with Chinese students.
Yeah, what? They would be in 10th grade and we'd be going to their 10th grade?
Yeah, something like that. Can we write that in the notes?
Sure.
Okay.
Just gonna burn these notes.
Really?
I don't know. I didn't even use my pre-calc, or I didn't use any of my notes from previous years.
What? Stupid.
Wait.
It's stupid.
Yeah.
Right.
We're so stupid.
Guess what? It converts.
Wait, what?
No, it was just really convergent.
I don't know what the difference is between converges and converges absolutely.
Look it up.
I did. That's what you get right there.
This is a stupid definition.
Exactly. But it has the slightest bit of importance, which is why I had to put it, because it comes, what we do with the ratio test next matters. There is a definition that just says if you take the absolute value of a series, and if you can show that that absolute value of the series converges, then the series converges absolutely. And if something does converge absolutely, then guess what? It converges. Wow. Okay.
Well, I guess that they say that because other tests don't tell you for sure who they
Oh,
converge,
I guess.
but they imply. That they
No.
might.
I think there are other things that can converge, but they don't have to converge in absolutely, as an absolute value. Absolutely.
Oh. That makes sense. Like it converge, like, but it's underneath the x-axis or something, but not necessarily its absolute value converges. But why? Oh.
Like, I don't know, e to the x.
That's no. That's
It
enough.
doesn't make sense.
But the absolute value of the x wouldn't.
Would it? Oh yeah, it would.
No.
Yeah. I can't think of anything. So whatever. Here's where it matters.
Jim taught it much better in this tent, and in
What?
a different way. Oh shit! Not near me.
Mike, I hate you.
Where is Bo?
Yeah, Miss Den, you want?
No, I
Wafers?
don't want any of your stolen goods.
They're not. They're one. I won a lot.
He worked for them.
Yeah, I had to work.
Nope.
You're just jealous.
Oh, you have to.
Yeah, I got a code. Work.
Okay, so
You have to do work to steal.
what is the difference between this series and the other series that we've seen? There's something very different. No, there is, for real. There's something that's totally different in this one that you haven't seen in any other one yet. There's 2 variables. There's an x. So far, all of the ones that we've talked about, at least when we've talked about tests, have had just n's and stuff with n's. They haven't had that x. And if I look at what the question says, the question doesn't say, does this converge or not? It says, find the radius of convergence. So it's telling me this converges. Find where. Everything else was like, does this converge? And if it does, what does it converge on? But this is telling me it definitely converges on something and tell me where. The reason why it's different is because I have an x. And there's going to be some value for x. It could be an interval, or it could be an exact point where this thing will converge. So this is where this thing comes in. When you get a problem like this, you're almost always going to use the ratio test. And I'm going to look at the limit as n approaches infinity of the absolute value of this function. Oh, shoot. No. I'm going to use the ratio test for it. I want to do the n plus 1 stuff. Sorry.
It's a good thing I know what this means.
Alright, I want to use the ratio test, so I'm going to use the ratio test for it, but when I use it, I'm going to use it in absolute value bars. Because of this stupid converges absolutely thing, if I use the absolute value bars, it'll make sense in a couple minutes. So I'm going to do the ratio test. I'm going to go n plus 1, x to the n plus 1, over 10 to the n plus 1, times 10 to the n over nx to the n. Just stay with it with the absolute value bars and wait till we get to the end to see why they actually are important. But try this. So absolute value bars is going to act like anything else. See if you can figure out, cancel what's supposed to cancel. Can you figure out what this limit is? Get everything reduced and then we'll go from there. Okay. So I reduced everything, like I said, I like to put all my similar things on top of each other. N plus 1 over n, that's not going to reduce. I'll get the limit, but it's not going to reduce. This one has the same base to a power, so I can subtract these powers. And I would get 10 to the negative 1, which is 1/10. And then the same base to the power, and I subtract the powers, and I end up just with x to the first.
You shouldn't reduce to 1 plus 1 over n.
There's really no point, actually, because what is this behaving like? N over n really reduces to what? 1. And this is 1/10. And x reduces just to x. I'm only plugging in n to infinity, so it's not like x is going to infinity, only n is. So the limit of this is just this. Well, remember, the ratio test says, when I take the limit of the n plus 1 over n stuff, what I get has to be less than 1, right? Well, the absolute value bars are what help me to find the radius of convergence. What I get has to be less than 1. So therefore, the absolute value of 1/10 x has to be less than 1. So therefore, 1/10 x has to be less than 1 and bigger than negative 1. And if I just solve this, I get the radius of convergence. I get that this is going to converge when x is between negative 10 and 10. Period. End of story. The n over n, because it's n to the first over n to the first, this is just behaving like 1. Because the plus 1 doesn't matter, so these are going to just cancel. If it was like n squared on the bottom and n on the top, what would that go to? 0. And if it was n squared on top, n on the bottom, it would go to infinity and mess up the whole problem. converges absolute thing is at all important is that when they ask us for the radius of convergence, we're going to put absolute value bars up. So then when we're less than 1, we can put this between 1 and -1 and solve it for x. So that problem converges anytime x is between -10 and 10. If x is bigger than 10 or less than -10, then that's not going to converge.
We also did the coefficient thing if the power is the same. Like 2n minus 1 over n is just 2.
Is 2.
Yeah.
Is 2, yeah. So anyway, the radius of convergence, when they ask you for it like that, whatever, is 10. Did we talk about that before? This is called the interval of convergence. It'll converge from -10 to 10. The radius is just half of that. So like, radius is what a radius seems like it should be, from the center to the end. So the radius is just 10. Is that okay?
Yeah.
Let's do well. Alright. Remember that paper I gave you with the examples on it? If you have it, get it out. If not, I'll put them up on the board. It was like double-sided and we only did the first few. We're going to do like the next few. There might still be some in the thing too. So it's this one. Erase some stuff. Like, I don't think we ever did number 5. It says, does this converge or diverge? Which is actually a stupid question. I shouldn't have worded it that way. The question really should be, this converges for what values of x? That's my question. Okay, because I have an x in there, you're not going to be asked whether it converges or diverges. You're going to be asked for what values of x does it converge on. And I guess it's possible there be none, but most of the times you'll come up with something. So try it. Use the ratio test. So we just got the n+1 stuff. This is pretty easy to subtract the exponents. It's 3x minus 2. And over n+1 again, that's going to go to 1. So this has to be less than 1, absolute valued, or between 1 and -1, blah, blah, blah. Yeah?
If it's something just like a simple fraction, do you have to go through the steps of like this over this, or can you just straight up put like the ones that look alike together?
You can do that. That's fine. Yeah, I just similar. It just, like, I think you'd be fine with it. Let's just skip it, go to 7. Just because 7 is a little bit different. So, again, question is, what is the radius of convergence? So, same deal. Whenever they ask that, you've got an x in the problem, so you're going to use ratio test. So try it and see what you get. Oh, I'm sorry. Do you know how to sheet out? This, yeah, this is the problem. Eric thought this was the problem.
Wait, isn't it M on the bottom?
Oh, yeah. When you're doing this, especially if it's an open-ended problem, try to remember to put the absolute value bars. I always forget. Okay, so what happens? So you get to this point where the x is reduced to x squared times 1 over n plus 1. So now it's different because this doesn't just go to 1. As n approaches infinity, this is going to 0, right?
Yeah.
And 0 times x squared, this limit is 0. Well, what does the ratio test say? What I get has to be what for it to converge? Less than 1, right? The ratio test says whatever I get, if it's less than 1, it converges. If it's bigger than 1, it diverges. If it equals 1, it's inconclusive. So this is always less than 1, no matter what x is. I'm just writing this down so you have it in your notes. But so no matter what x equals, this thing's always going to converge. So the series will always converge. So therefore, what values for x can we plug in? All of them. Yep. So the interval of convergence would be negative infinity to infinity. And the ratio, I'm sorry, radius
Half of infinity.
of convergence would be infinity.
No, it's half
again.
of 2 infinity.
So if this happens, I ended up being able to not reduce this to 1. So when I plugged in infinity, this goes to 0. Well, that means for every value of x that I plug in, it's going to converge. So the radius of convergence is infinity. Get it?
Got it.
We're done.
Done?
We're done. Tomorrow we got to talk about what actually happens at the end points, whether it converges or not at a third and at 1.
Does it?
You got to go do the ratio test when x equals a third, and the ratio test when x equals 1, and see separately. 'Cause sometimes it both happens, sometimes neither happens.
Does
All right,
one
so
ever
try.
So X.
Sorry.
Surprise food. That's the best kind of food. This is just like high school where you see the graph. No graph except where it shows you there's a graph.
Yeah, study hall again?
All more physical. Yeah.
I'm so tired.
That's so water that helps.
The line that it'll follow. Makes it a little easier.
All right, I would try these. you had the answers already, so I would try them without looking, and then
That's from highway, though? From 1912.